Our lesson for today will be looking at chemistry 1502. The topic for today, we are looking at alkene reactions. We are still busy with part 2 lesson series. The process for today, or the mechanism of today, we are going to look at hydration, but we are not going to use acid as our catalyst, but we are going to use Oxymercuration Demercuration process. Lesson 105, let us start. The previous lesson video, we've looked at hydration of alkene, whereby we add water onto alkene, but using an acid. Now in this lesson, we are going to perform hydration by using Oxymercuration Demercuration. We are not going to be using an acid. The reason why this process is performed is because some of the alkenes, or let me say many alkenes, do not easily undergo hydration in aqueous acid. Some alkenes are nearly insoluble in aqueous acid, and others they undergo side reactions such as rearrangement, polymerization, or chairing under these strongly acid conditions. And also in some cases, instead of the production of alcohol, we produce alkene. So the Oxymercuration Demercuration process is another method to convert alkenes to alcohols with Markovnikov orientation. And this process, it works good for those alkenes that cannot undergo direct hydration. And you should also know that with Oxymercuration Demercuration, there's no opportunity for rearrangement. So we don't have rearrangement whereby the carbocation ion, actually let me say, we do not form, carbocation ions are not formed at all. So if the carbocation ions are not formed, it simply means that we cannot have rearrangement. So in Oxymercuration Demercuration process, we don't have rearrangement. Now, as usual, we know that alkenes are simply double bonds. Double bond between carbon and carbon. And for the Oxymercuration Demercuration, you will see something like this. We're going to explain this. And then we have if you see something like this within the reaction, just note that it is Oxymercuration Demercuration. Now let us start with the general mechanism. But before we look at the general mechanism, we have mercuration. We should know what is a mercuration. Mercuration is a mercuric acetate. The molecular formula is HgOCOCH3, and then we have two of this. The Lewis structure, it is like this, whereby we have mercury with lone pairs, we have oxygen, and then we have this part here. You can see that we are saying this part, we have two of these. So if you can check this and this, it's the same thing, they're identical, and then we have our mercury here. So this is the Lewis structure of the mercuric acetate. We are trying to understand where does this name mercuration comes from. So normally the abbreviation of this, I'm talking about this Lewis structure, you will see something like this, Hg, which is the one that I've just written on the previous page. This is mercuric acetate, and then normally what we use mercury species. Mercury species, it's one of these. If we take this part, we call this a mercury species, and then we can write it in this manner. It's HgOAC. Since we only have one of this, we don't have two here, but we have one, and then it is positively charged. So it is important to take note of this. You will be seeing more of this when we are dealing with the mechanism. Then to explain the last part of the reaction, which is demercuration, we are going to explain it when we are looking at the general mechanism. Now let us start with the general mechanism. Step number 1. Suppose we have an alkene reacts with mercury species. The name of the first step, we say it is the electrophilic attack to form mercurium. Actually, let me get this name correct. It's mercurinium ion. So that is the first step. We have to form the mercurinium ion. So we have the species, mercury species, and it has the 2 electrons here. So what happens, we can say it's a two-way step. The pi bond attacks. At the same time, this double bond attacks this carbon. It's an electrophilic attack. So you can see that we don't have the rate limiting step whereby the carbocation ion it is formed. Therefore, we don't have any rearrangement. Our product, we are going to have something like this. We have Hg, which is plus, bonded to OAC. And this product, we call it mercurinium ion. Or we can say this part, we call it a mercurinium ion. And then step number 2. This process is very simple. Step 2, we have water. Remember that at the end of the day, we have hydration. Hydration is to add water. So in step number 2, we have water which opens the ring to give an organomercurial. This name, organomercurial alcohol. I'll have to write the name down. Or sometimes these words, they can be challenging to pronounce them. But that is chemistry for you. So let us write our mercurinium ion. Then we have water. I think this color is not visible enough. Let me use this H2O. So in this case, we have water which opens the ring. Then at the same time, this bonds will move to the mercurinium ion. And then this will give us remember that whenever we have water, just think about deprotonation. So we have water here, and then we have OAC. Then in this case, we have another water molecule. To deprotonate, it deprotonates one. Oh, by the way, before I make any mistake, we need a double bond here. Deprotonation, and then these electrons will move to oxygen. And then we have CC, we have OH, and then we have our species here. So since we have an alcohol, we call this an organomercurial alcohol plus H3O. And then the last step, we call it a democulation, whereby we replace the mercuric fragment with hydrogen to give an alcohol. So we don't need this mercuric fragment. So you have to replace this with hydrogen. How do we do that? We use demercuration. So the last step, we take our organomercurial alcohol. Well, I'm getting better at pronouncing this name. We react this with by the way, we call this sodium borohydride. It is a reducing agent. It actually replaces the mercuric fragments with hydrogen. So this will form OH. See, we have H here. Plus OH, you can say 4, plus our mercury atom plus this, because we need to see this, but when dealing with mechanism we don't have to show the remaining products. Now let us look at the examples to consolidate this mechanism. And before we continue, you can see that this is an alcohol. Remember we said if an alkene undergoes hydration, the product is an alcohol. So let's say we have propene. We know that propene, looking at the previous lesson video, we've seen the product. So let us see if we use oxymercuration demercuration. It will produce the very same products. So we start with mercuric species. Hg, OAC. Electrophilic attack to form a mercurinium ion. To form Then we go to second step, whereby water opens the ring to give an organomercurial alcohol. OAC. Then we have our water, H2O. Then at the same time we have this movement of electrons here to form here we have Hg, OAC, and then here we have OH. Then we have the deprotonation, H2O, whereby we extract one hydrogen, then these electrons will come here. And then we have OH, plus H3O plus. Then from here we need a demercuration process to remove the mercuric fragments. We are going to use sodium borohydride. The product will simply be propan 2-ol. Then we know that our hydrogen will be here, which was removed, or which was replaced. Let me say which was replaced by the demercuration process. So you can see this is the major product. For the next example, I will leave it for you to do it. Then you know that, as usual, you get back to me with an answer. So we have 3,3 dimethyl. Put 1 in. It undergoes Oxymercuration Demercuration, HgOAc2 H2O. Then it will also go demercuration. Normally you will see it will be written in this manner. Just know that it undergoes two processes, oxymercuration, demercuration. Should the question require you to react this under oxymercuration, you will simply use this only, and the product will be your final answer. Demercuration, you continue. I'm replacing the mercuric fragments with hydrogen. Let us put another one. Number 3. We only need, let me not actually explain this question. Let's see if you will be able to nail this. We react this under these conditions only. H2O. So yes, I will only need the major product. That's it for this lesson video. This is Fahula SJ. Thank you very much.